circuit.
In this problem, we have a circuit which asks us to find V naught and also asks us to find the total power observed in the circuit.
In our diagram, we have voltage and a lot of resistance. For part B, it is important to note that they asked us to find the total power absorbed. The reason why it's absorbed is because we have so many resistors, and this is going to come into play when we actually try to go and calculate the total power that's absorbed. First, we're going to find V naught, but before we even do that, we're going to draw a few things that we know in our diagram. First is the way our voltage is going. It's going into the positive and out of the negative, so we can draw these lines denoting their direction like this. Next, we can draw the current, and the current is represented by this triangle, and it is going up and down into a resistor, out of our resistor, into this node, out of this node, and up into this resistor, and then into our 20 volts here. Again, we're going to be dealing with absorbed current, not really delivered current, so this is not going to matter too much, but it is still important to note. First, we're going to look for our V naught. Our V naught is over here, so we're going to look at this first. To find V naught, we have the current right here. We also have the resistance. Since we have both of these, we can use the equation V naught is equal to the current times resistance. And our current is going to be Vx over 100, since the triangle represents current. We don't know V of x. It's given to us over here, but we do not know it yet. So what we can do is solve for it. Since we're looking at this left part now, we have to see all of the resistors in here. We have this first resistor, and then we have this second resistor right here. It's important to note that they are in series. And since they are in series, we can use the voltage divider formula that is located in section 3.3 and 3.4, voltage divider and current divider. Those notes are linked below in the description. But the formula that we are going to use is going to look something like this. We are going to have our Vx, and that is equal to our Vs. And our V of S is just the initial voltage that they give us, so this is V of S. And this is being multiplied by the resistance that's associated with our V of X. So we're going to multiply it by this resistance. We're going to call this R of X. And then after this, it's going to be divided by the resistance total. This is the resistance of this 450 ohms and this 150 ohms. So now we can plug everything in. Again, our Vx is unknown, so we're just going to leave it unknown. We're going to have our Vs, which is 20 volts, and then we have our R of X, which is 150 ohms. This is being divided by our total, which is 450 ohms plus 150 ohms, or 600 ohms. After we plug this into a calculator, we can see that our V of X is equal to 5. So this is what our voltage is that is passing through this 150 ohm resistor. Now that we have this, we can plug it into our previous formula when we were trying to find V naught. We plug it in up here. We have V naught is equal to our V of X, which is 5, and is being divided by 100 times our resistance, which is 300. After we do this, we'll see that our V naught is equal to 15 volts. So this is the answer for the first part. We have 15 volts here. Now we have to find the total power absorbed in our circuit. Normally when we do this, we would use the formula voltage times current. And since we have multiple different voltages in here, we would actually have to do the summation, where we would be adding the left side to the right side. However, there is a slight problem here, and the slight problem is that we don't have current on our left side. Instead, we have resistance. So if we look into the notes, again linked below, in section 2.3 at the very end, we're given a couple of different formulas to find power that's actually derived from the voltage times our current. And the different formulas that we're going to get is the sum of our power is equal to voltage squared divided by R, and the sum of the power is equal to our current squared times R. Again, these formulas can be found linked below in the notes at section 2.3. In doing this, we need to look at what we have. We're going to look at the left side, and we are also going to look at the right side. Well, for the left side, we do not have current. And since we don't have current, we cannot use the formulas with current in them. So we can't use this formula, and we cannot use this formula. That leaves us with the sum of power is equal to the voltage squared divided by R. So we are going to use this formula. We have the sum power is equal to, and then we have our voltage squared. So for this, on our left side, we're always going to use the max voltage, the voltage that we start with. This voltage is 20 volts. So we're going to write this here, and then we have the resistance, the total resistance around it, and that is going to be 450 ohms plus 150 ohms. Now we have to look at the next side. In this next side, we have our V0 as our voltage, and this V0 is 15 volts we found to be, and then this is being divided by our only resistance, which is 300 ohms. Before we plug this into a calculator, we have to remember that our voltage is squared. So we're going to have 20 squared on top and 15 squared on top for this side. If we plug this into a calculator, we are going to get the total voltage is equal to 1.42, and this is in watts. So our answer for part A is 15 volts, and our answer for part B is 1.42 watts. And these are the total answers for this problem, as well as the way to solve it. If you found this video useful, consider giving it a like. If you have any questions about the material we covered in this video, leave them in the comments below and we'll get back to them as soon as possible. If you want the notes for this and the notes surrounding this chapter, as well as playlists to problems that are similar to this, they will be in the description below. If you want more content like this, you can hit subscribe, and that would help me out greatly. Thank you, and good luck on your studies.